This video is going to piggyback on the previous law of signs video that I made, um, and it's just going to deal with something called the ambiguous case for law of signs. Okay. And so yesterday, all the triangles that we saw, let's say yesterday, whenever you're watching this video, the previous video on the previous law of signs problems that we did, all the triangles were either angle side angle or angle angle side, and I was able to solve them. Okay. Well, there's an ambiguous case if it turns out to be side side angle. I like the way that they ordered that to make sure they didn't spell a bad word on my smartboard here. So thank you, geometry people or trig people, whoever did that. And the ambiguous case is just saying that whenever you're solving a oblique triangle and it gives you a side and an angle, sometimes you're going to have more than one triangle that may satisfy that criteria. And so that's the first thing I want to go over today, is I want to fill in this table as to what's going on with some of these. Okay, now, first of all, we are going to have just a regular triangle, and we're going to be dealing with the height of this triangle. And that height's going to tell me whether or not I'm going to have 1, 2, or as you can see on this table, maybe even 0 triangles. Okay? And I'm going to be given this angle A down here, and this is going to be my side B right here. And so I know good and well that sine of that angle A, like we've been doing in the previous videos, is going to be h over b. So I wanted you to see where this little formula was that this came from. It's definitely just SOHCAHTOA, that b sine of A is definitely equal to h on this. Okay? So keep this in mind whenever we're working through these. Now, I'm not going to draw a bunch of little triangles on this. I'm even going to draw a triangle for each one of these, so just hold on or draw them with me or whatever you want to do. Okay? But suppose that I do have an acute triangle like I drew over here, and it looks like I'm going to be using alpha instead. So first of all, make this a lot bigger. And I'm just going to make the bottom straight, and this is my alpha right here. Okay? It says that if you have your height h right here, and I'm doing this first line right here, if you have the height h right there, and then the side that's across from alpha is going to be my a, if it is shorter than h, there's no way for it to come down. I cannot form a triangle if a is shorter than h. I got a shortcut for that we'll look at in just a minute, okay, but just keep that in mind. Now, in the rare occurrence, on the second part right here, if you have a is equal to h, then I'm going to be able to form one triangle. I'm going to be able to bring a straight down. It's going to be the same distance as h, and it'll form a right triangle. That won't happen very much because we already solved a lot that looked like that. Okay. Here's the ambiguous part. Okay, you have this height h right here, and what happens is that your a is a little bit less than b. Remember where b is. Excuse me. Phew. A is a little bit less than b, but it's longer than h. What happens is there's 2 possible triangles that can come down for a. A could come down like so, and then you get this green triangle right here, or a has the possibility of coming down like so. Both of these distances for A are the same, and then you end up with this larger black triangle. So there's 2 different triangles that can happen there. And again, the big kicker for me that I can tell on that is that B is just a little bit smaller than A. I don't plan on being very hard to figure out as far as when you're going to have 2 triangles and when you're not, especially with the situation that we're in. And so that information will hopefully be given to you. You just have to be able to look and find it. All right. Now, the last scenario that we have for this, I'm going to redraw my triangle because I did so much drawing on it, is that if I have my height right here, I'm struggling right now, guys. I'm struggling. All right, there we go. And that my A, side A, is longer than B. Well, that can only happen one way, is if A comes way over this way and connects with this line. I still have my height here, so I wasn't really contingent on it. Guys, on these where we have 1 and 0, those triangles are just going to solve the same way they did in the previous video. And there are some of those that I've picked out for you to solve. A little bit different on the work, but not too bad. Okay. The other case I have that we'll see a little bit of is whenever A, or alpha, turns out to be obtuse. So let me draw a nice obtuse angle right there for alpha, bigger than 90 degrees. This is still side B right here. And they're saying that you will not be able to draw a triangle at all if A is not longer than B. There's no way for A to come down and meet that bottom line that's away from B unless A is larger than B. And then in that case, you only have one triangle that you can solve. And so what we're going to be looking at today is that it will give me a side, it'll give me a side, and it'll give me an angle. And then I'm going to show you in this video how to figure out if there's 1, 2, or 0 triangles. Now, I'm going to try to make this as foolproof as possible. I'm going to overteach this, and then we'll hit an easy button on it, all right? So, first up, I want to make sure there is a triangle, all right? So what I can do is I can take my little formula over here, and I can plug in 14 in for B, and then the sine of 60. And that will tell me the height of this triangle. Well, I'm going to go grab my calculator. I put it back at my desk. I was trying to work a couple of these before I started the video. If I do sine of 60, I know that's a nice angle. This is square root of 3 over 2. I don't know what that is. I mean, 0.86 something. Times 14, that gives me 12.12. So the height of this triangle, if I was to draw everything out, would be, let me draw it. 12.12. All right, where this side is 14. If A is only 4, there is no way for this to come down, and there is not going to be a triangle possible. Some of you might be thinking, okay, what's this bald guy doing right now? All I know is how to do the law of sines from yesterday, and that's good news, because watch this. If I was to just not do any of this work on the right side of the screen right here, and I was just to jump in and say, oh, guess what? I know sine of 60 degrees, and I know the side across from it. I want to find, it's a little bit different today. I'm going to find angle B because I know the side across from it is 14. If I was to go through and work this, I know I'm going to get 14 sine of 60. That sound familiar? Equals 4 sine of B. Okay, and then I divide both sides by 4. So I get 14 times sine of 60 degrees, and then that divided by 4. I get 3.03. Haven't found my final answer yet, so I'm going to keep an extra decimal. Now, in order to find out what B is, remember I'm going to take sine inverse of this. So B will equal sine inverse of 3.03. I don't have to do that in my calculator. You can go ahead and do that in your calculator. I know good and well my calculator is going to say error. Okay, we talked about this in previous weeks where if I am taking sine inverse of something, it has to be between -1 and 1. Remember, if I graph sine, it sat there and oscillated between 1 and -1. It never went outside there. 3.03 is way up here. It's never going to come up here and touch that point. And so I'm good. There's not going to be a triangle possible. So my final answer on this is just no triangle. No triangle possible something. Let me know there's not an answer. Okay? So you have two ways to get at it. You can just start working the problem like we did in a previous video, and then you get a calculator error. No triangle possible. Or you can just say, hey, A is only 4. There's no way it can come down and touch whenever the height is 12.12. Okay? Good deal. Smell an ambiguous case coming on. I remember the order of these correct. Try to leave this little triangle. It's rather helpful, okay? Again, I plan on telling you when you're going to have two triangles. If I forget to tell you, that's going to be my fault, all right? But I plan on telling you, hey, on number 3 on the quiz, check for that ambiguous case, something like that. So you just got to know how to get to the two triangles. But sure enough, if I plug in what I know on this, using my little chart, I get 12.8 sine of 58. 12.8 times sine of 58 degrees. 10.9. I'll say 10.9 for the height. 10.9. Look at my A. I'm not going to redraw this, but my A is sandwiched right between the length of that leg and the height. So that means that I am going to draw it. I can't help myself. That means that this A could come down possibly two directions right here. And I need to list both of them. Okay? Like I said, I plan on telling you when this is going to happen. And the good news with this is that the problem is just going to start working regularly. I got sine of A over A equals sine of B over side B, 12.8. My 0.8 got a little bit high there, but it's going to work. And I can definitely solve this down for B. I'm going to go ahead and show you this time since it's going to work out. 12.8 sine of 58. Oh, I got on the wrong side. It'll work. 11.4 sine of B. I guess that's the way I went yesterday. And so I divide both sides. I'll divide both sides by 11.4. And I get sine of B equals, let's see, 12.8 times sine of 58 divided by 11.4. It gives me 0.9, I'm going to keep several decimal places on this, 0.9522. Okay? Now, a sine's going to switch sides right here of the equal sign, and it's going to become sine inverse. It's actually, I'm taking sine inverse of both sides, and the signs cancel. But either way, I'm looking for an angle. I have to introduce an inverse trig function, which in this case is always going to be sine. So I hit second sine inverse of 0.9522, and it gives me, and we'll just round angles, I'm going to say to the nearest whole number, 72 degrees. Okay. Next thing we did yesterday was we took again we can now find angle C, right? Angle C, there's going to be 180 degrees in this triangle. 180 degrees minus the 72 I took up on angle B minus the 58 degrees I took up on angle A. Again, I'm recording this, so I do not want to have any errors because I don't have the sweet editing software that I need to do multiple takes on this. Hopefully it's going to be 50 degrees. Okay, and then the last step, now that I know 50 degrees, I've got my I've got angle A, B, and C, and I have sides A and B. I need to find side C. So side C, I need to use the sine of angle C that I just found over C, which is what I'm looking for. And again, I'm going to use what they gave me up here. That's the safest thing to use, is this sine of 58 degrees over 11.4. That way, my answer is not contingent on too many previous things that I found, including that this angle B equals 72 degrees. Okay. So, I'll do the math on this. C times sine of 58 degrees equals 11.4 sine of 50 degrees. And I'm going to divide both sides by sine of 58. Now, some of you thinking, well, he's not using sine inverse this time. That's correct. I am finding side C, not angle C. So I don't have any need for that sine inverse on this one. So 11.4 times sine of 50 degrees. I'm going to divide that by sine of 58 degrees. We're doing one decimal place on the side, so 10.3. And yesterday, that's where you pump your fists in the air and say, woohoo, I got it right. Today, as we just talked about, this is the ambiguous case. So what that means is, let's go back up here to this original triangle I drew. I'm going to use green on it. So let's see, angle C, this is angle A, this is my alpha down here. And then A was the same, 11.4. B was 12.8. Angle C was 50 degrees. So angle C was up here. So it was 50 degrees. It was actually cute. So what we just found, I'm not going to label it all because it's not, you don't really need it. But what we just found was this green triangle. We still have a whole other triangle to contend with, this red one. All right, so I'm going to go back through and I'm going to put like angle C1 on this. All right, so that Mr. Lovelady knows that this was the first triangle that I found. I'm going to erase this because I have to find a second triangle. Watch the steps on what I do to find the second triangle. Okay, I'm just going to work everything in the same order except for I get to start all the way down here. And I'm here to tell you that angle B right here, this angle B we found was, you know what, I said that backwards. I said that backwards. Okay. We just found, I'm sorry, backtrack everything I just said. We just found the red triangle right here because D is 72 degrees. That makes a lot more sense for B right here to be 72 degrees. Sorry about that. I had it right in my head, just said it backwards, jumped ahead of myself. And so what we have to do now is we have to find this green triangle right here. So I'm here to tell you that this B1 right here and this B2 right here are going to be supplementary angles. I can draw some parallel lines and prove it to you. Bring it up in the Q&A if you have some questions on it. But I'm telling you, finding it in the same order, I have to find B2 first because I found B1 first. B2 is simply going to be the supplement of B1 every time, I promise. All right? I'm pretty sure that gives me 108. And so I have my B2 already. So I saved myself a full law of sines right there, okay? But from here now, again, I'm looking for this little triangle. I have to find this little bitty angle C that's up here, okay? This up here is going to be my angle C. So my angle C is still going to be this alpha, which we said was 58 degrees. Sorry, 180 minus that little alpha, minus this B2 I just found, which was 108. So yeah, sure enough, I'm not sure what that is, but that's going to give me something that's a lot smaller than my previous C. 180 minus 58 minus 108. 14 degrees. Look at our drawing right here. Does that make sense for this little bitty guy to be 14? The previous C that we found, this 50 degrees, was this whole thing right here. So yeah, this little c is only going to be 14 degrees. I'm going to call it angle C2. C in my second triangle. And then from there, be super careful from here. I'm just going to do law of sines and find the side C, I'll call it C2, right, using this 14 degree angle. That will tell me what this little side down here at the bottom is. Okay, I'm going to go back and use my boys here, 58 degrees and 11.4. So I got sine of 58 degrees and 11.4. Okay. And I get my C2 times sine of 58 degrees equals 11.4 sine of 14 degrees. Have you started racing on the calculator yet to see if you're faster than me? And so, yeah, I expect C2 to be a lot smaller. The original C1 I found went across this whole bottom right here, which was 10.3. So, yeah, C2 should be considerably smaller, and I did get it to be considerably smaller, 3.3 on that. 3.3 units. I'm not told what the units are. It could be centimeters. But as you can see, man, I have answers floating around everywhere. 6 answers on this one, but I've conveniently boxed them all in, circled them all for my teacher to find. A lot of work to find on that, Jump ahead to the answer. If you're having trouble, recognize when there's two triangles or not, okay? And then work forward with it. I'm going to let you play with this one. So hit pause on the video and then see if we get the same answer when we come back. This is what I got. You can definitely let me know if they got something, if you got something different during the Q&A. Man, look how much bigger A is than B. There's only going to be one way for that thing to come down, and so it cannot come down this way and meet up with that side. It just cannot happen. And so, just a straightforward law of sines there, just like we had in the on the previous video.